Hey, what's going on, guys? Melendez again. Doing a little quick video. Hopefully, you guys saw the last video. We talked about fittings, crimpers, strippers, and a little bit of continuity and how to use your meter. Today, I'm gonna talk to you guys, and some of you guys are in my Zoom class when the mod first started. Talk about transformers, right? Not only that, We're gonna talk about a little bit of the components inside of a system electrically. So, first thing we're going to talk about is actually going to be this little guy right here. You guys can see that, right? There you go. This guy here is called the contactor, right? So the main purpose of the contactor is this guy is the one that receives the power, the incoming power, the 208 volts from a disconnect or its main power source, which is going to be PG&E. Right, so it comes into a disconnect, which is where we go, just the name says, disconnect the power from the unit. That way we can isolate the unit and actually work on it safely. So after disconnect, the first point is going to be this guy here. So this guy has multiple functions. So one of its main job is to, like I said, receive the power, right? Second job is to distribute some of this power. And his third job is of course to fire up the compressor and the condenser fan motor, which you guys next mod will learn about. So this guy here, you guys can see that, right? You see that it has this little clicker right there, right? So if we look on this side, it's a straight piece of brass that comes straight across. And on this side hits a set of contacts, and then another set of contacts here. Well, this guy here, you guys can see it's right here. It's pointing over here, but it's here, all right? Once you push this guy down, see if I can get a better angle on this. Once you push this guy down, it closes that set of contacts. So after this guy gets pushed down, it basically acts like this solid piece that's on this side, all right? It basically allows power, incoming power that gets hooked up here, right, to get sent up here. So after this set of contacts closes, power is up here. So it goes through here, comes over here. All right, so on this guy, what you guys have to understand is once the power is coming in, I'll hold it to you like this. So the power is going to come in on here, right? This guy is considered line voltage, right? So that's your incoming power, line voltage. And then as it exits or leaves, it's going to come out on this side. This guy's going to be called load voltage, right? So if you're thinking a little bit, lines coming from your line power, right? And this guy here is coming or going to a load, electrical load, meaning a motor, another relay, something that's going to consume this power and create energy, right? So that's why we call it a load. It's going to a load, okay? And then you guys can see down here, all these strands of copper. This is actually the coil. So what happens is, here, like I said, you guys have incoming power coming here. Then down here, you actually have a positive and negative, or a positive and negative, however you guys want to connect it. It doesn't really matter as long as you have a positive and a negative on this side. Down here is actually going to be 24 volts. Over here, you're going to operate anywhere from 110, 208, 240. On bigger contactors, you're going to be operating, 463 phase power. But for this guy here, it's going to be, 208 volts. But down here, we're actually going to operate on 24 volts, right? So those 24 volts are going to energize this coil here. Now, when we energize this coil with 24 volts, what's going to happen is that coil is going to generate a magnetic field. And that magnetic field is going to pull down on this plunger that sits up here. So once it pulls it, closes contacts, and allow the voltage that's down here to actually travel and come up to the top. And this will actually go and feed a compressor, condenser, or blower motor, whatever the case may be, right? So this guy here is a contactor, right? Now, we talked about a transformer, right? So a transformer is going to be hooked up directly to that guy on the line side, on the incoming side, right? You guys got to remember that anything that's coming in to that contactor, you can tie into that guy, and you will always have power coming out of it, because that guy will not shut down. It will stay constant as long as that disconnect is active, right? So this guy here is going to get set up to the line side of that contactor, so we can always have power, right? Now, if you look on this guy here, you will see that this guy has, different voltages, right? So it tells you, we'll go from this side over here, 240, it's going to be hooked up to an orange wire. 208 is going to be hooked up to red. 120 volts going to hooked up to black, and then common is going to be hooked up to white. Right? That's going to be, and you see here it says pri or pre. That's primary winding it's talking about. Then down here at the bottom, this will be your secondaries. Secondary 24 volt voltage, green and red. Right? So just like it says, if we're operating on 208 volts, well, we're going to look at the top of this transformer here in white. It's going to be our common, so we'll leave that guy here. And then we're going to use red. I'm sorry, we'll go with red. Right? So we're going to hook up 208 volts to these two lines here. These lines here will get capped off, move to the side. Right? And then coming out of these two guys now, red and green, this is where our 24 volts is going to be operating from, or coming out of, I should say. So we're going to take voltage coming in through here, high voltage, 208 volts, and then transforming it to 24 volts, right? And just like I told you guys, a few minutes ago, this coil here for this contactor operates on 24 volts. Now, what you guys have to understand, you have two types of voltages, right? In any type of systems, you have your working voltage, right? Stuff that's going to turn motors or turn on a motor and turn compressors and stuff like that. Big power, 208 volts to 460 volts, depending on the system. And then you're going to have small voltage, control voltage, right? This control voltage is just like the name implies. It's going to control the equipment. All right. Now, what I always tell my students is think of a heavy load machine, right? Heavy operating machine. The one I always use is an excavator. You guys know what an excavator is. It's the one with the big arm, right? Digs a bunch of holes. All right. What does the job? Does the excavator do the job, or does the operator do the job? Right? It's the excavator. Excavator is the ones doing all the digging, doing all the work. All right. But what's telling that machine to do the work, to perform, how to perform the work? It's the operator. So if we take that little scenario there, the big machine is the high voltage, it's 208 volts, 240, 480 volt. That's the one doing the big work. And then the operator, the guy who's actually driving the machine, that's the control voltage, right? That's basically what's going on right here. This is why we need this transformer. It's going to drop it down to 24 volts, and that's going to be doing all the main controls, right? So when we're talking about controlling stuff, we talk about relays, right? So this little relay here, right? This guy here is called a peanut relay. So if you guys look down here, you can see it has 5 pins. So the bottom pins are going to be for our coil, our 24 volt. And then at the top pins, here, these 3, they're going to be for high voltage, right? So you're going to have a line that comes in to this post here, which would be post number 2. And then you have 5 and 4, right? Well, you guys can't really read it. Hopefully you guys can make this thing out a little bit. Camera's not cooperating. But what it tells you is that, hey, if you hook up high power to pin number 2, when this unit it's not running, meaning there's no 24 volts energized down here, between 2 and 4, sorry, 2 and 5 are going to be active. So if you hook up 120 volts here, there's going to be 120 volts present down here, right? The minute you apply 24 volts down here, it will disengage pin number 5 and it will engage pin number 4, right? So this is a way we use relays to control equipment, right? So we're bringing power here. Nothing's going to happen because the thermostat is the one that's doing all the communicating. But it's not calling for anything. It's not asking for anything to come on. So we're going to have voltage down here. We can leave this on cap and it'll sit there. Nothing will happen, right? And then we can actually hook up the motor to this side. So when the 24 volts are sent down here and it energizes a small magnetic coil that has inside of it, when that little guy receives those 24 volts and sees that, it's going to create that magnetic field, and it's actually going to switch contacts. So it's going to keep power in here, but instead of feeding straight down here, it's going to cancel this pin number 5 down here, and it's actually going to activate pin number 4. So the power will actually go through here, go straight across, and come out and go into our motor, right? Now this is another way that we control motors, right? So you guys got any questions about this stuff, again, hit me up and I'll answer it, right? So that little relay, what it's doing is basically doing this guy's job right here. You guys can see here, this is a control board. So this is a lot more sophisticated, but as sophisticated as this guy is, this guy also has relays, right? All the circuitry in the back, you can see all that stuff there, but that relay there, it's old school. That's older technology, but it's still good technology, right? But it's basically in here. It lives here, right? So the way we like to teach here is that we like to show you all the old stuff, because the way I was brought up in the trade, if you can troubleshoot and diagnose old stuff, you should have no issues with the newer stuff. It is actually a little simpler, a lot simpler, I should say, because you know how to diagnose, you know what you're looking for. If something is not right, a motor's not firing up, you know the proper procedure to go through, so you can actually troubleshoot and diagnose, accurately and efficiently. And this guy here is another type of relay here, but the difference is that guy actually operates on the magnetism, right? Induction. Where this guy here, actually, if you guys can see that, I don't know if you guys can. Well, this guy here has a small little bimetal strip inside, right? This guy here actually operates on heat. So it has a bimetallic strip there. So it's basically a piece of steel and brass put together. Now, when it heats up, they're gonna bend, right? Well, that's what this guy's doing here. This guy's actually gonna sit inside of a furnace, right? Like that. And as the chamber out here is getting hot, it's gonna warp that piece of bimetallic strip there. And it's actually gonna close a set of contacts down here, right? So there's multiple ways that we control equipment. We can use it. We can either turn them on by using magnetism or metallic strips, bimetallic strips, right? So there's all kinds of ways we can get our equipment to actually turn on for us and operate. What else was I going to talk about? All kinds of ways. And then I'll leave you guys with this. I'm trying to keep them short so I can upload a little bit faster. We have our thermostat, right? Now our thermostat, the main job of this thermostat is it's going to take those 24 volts that came out of this transformer here, right? It's going to take it, and it's going to take it through a red lead, right? It's always going to hold 24 volts at the thermostat. Now, what this guy's doing is whenever you call for cooling, right? We'll call for cooling. This guy here is going to send those 24 volts out to the relays that pertain to cooling. That's to kind of tell them, hey guys, wake up, let's energize, close the contacts. Let's go ahead and turn on these motors, right? Whatever motor's wired to that yellow series, or yellow circuit, I should say, is going to activate, right? So that's all this guy's doing. It's switching those 24 volts. It's taking those 24 volts and it's giving off to the yellow for cooling, right? Or it'll get those 24 volts and it'll give it to the white, the heating circuit, right? And it'll tell them, hey, everything on this white wire or on this heating circuit needs to be activated. All right, and then the green, which is going to be for our fan, or take those 24 volts, be like, here, green wire or fan, any relay that's hooked up to this green wire, go ahead and activate, turn on, and that's the way it works, right? So this guy here is basically what distributes those 24 volts. So this guy here is if you want to say, it's your brain to distribute the 24 volts that we're generating, that we need to turn on pieces of equipment, relays actually, and then those relays turn on the big pieces of equipment, right? So there's a whole lot of things that I hope to answer in these videos, but really I need a lot of feedback from you guys. If I say something that you guys aren't fully understanding, please text me, email me, call me. I'll explain everything I can. Hopefully this whole Corona thing ends soon, and we can actually get back into these classrooms and actually start, learning the trade that you guys are getting into. But like I said, I'm gonna keep this guy short. I'm about 15 minutes here, so hopefully you guys see this and come up with some questions, or something clicks inside your brain, like, oh, okay, that's how that works. But please, you guys got to communicate with me, and that way I can kind of make these videos more catered to you on what we need to work on, what you guys are kind of in the fog about. But I need input from you guys, all right? So I'll make another video here in a little bit that's going to talk about different circuit, but I need info from you guys, all right? So I'll see you guys on the next one, all right?